Welcome back. We are now doing Circumference of a Circle, Lesson 29, Part 4, the last question, question number 6. And if you've been enjoying these videos for this lesson, especially for the last one, helpful to you, please leave a like for the videos and just appreciate your watching and all. Hopefully you've been writing down notes and keeping up with the work as well too, because the answer is never as more important, not as important as getting how we got the answer. So the process is more important than the end result, at least for the learning wise. And so, ladies and gentlemen, question number 6: semicircles and quarter circles are types of arc lengths. Recall that an arc is simply part of a circle. We learned about the degree measure of an arc, but they also have physical lengths too. So determine the arc length to the nearest tenth of an inch of this quarter circle here. And so we have now the following. We have in this case a quarter circle where the radius of this quarter circle is going to be 6 inches, and the quarter circle is basically in this case the arc is intersected by a 90-degree angle, and so the central angle is going to be the same measure as the arc intersected. So if we were to draw a circle, okay, and actually you know, the idea is that you know, I can just see, I have a circle right here actually, so just erase this here. Okay, and so here, the idea is that the measure of the arc is going to be this arc here that we're dealing with before, is going to be also 90 degrees. So the portion of the arc of the 360 is going to be the portion of the full circumference. So we know in this case, the full circumference is going to be 2 times pi times r, which is going to equal to, in this case, 2 times pi times 6, which is 12 pi. But we don't want the full amount though. And so we're going to take, in this case, a fraction of this. So we're going to do 90 over 360. 90 degrees over the total 360 is equal to, in this case, n, the measure of the length of the arc, over 12 pi. And so here, we are going to just kind of cross multiply here, and we'll get, in this case, n equals 1/4 times 12 pi, which is n is equal to 3 pi. Now, to the nearest tenth of an inch though, so this is the key thing. As for the nearest tenth of an inch, we're going to now evaluate that. And so we break out a calculator, we're going to clear our screen, and we're going to do 3 pi. So 3 times pi, and that's going to be a little more than 9, which is 9.424777961. But to the nearest tenth, 9.4 inches. So in this case, for A, we get 9.4 inches. And so this is the answer for A. Now I hope in this case that when we see this null, that again, just not the answer. You're going to show how you got the answer though. If you knew that's 1/4 of a circle, just say 1/4 of 12 pi of the full circumference, that's totally cool too, because you get the same exact answer. And now I'll explain why the portion would solve for the length of arc AC below. In this case, this is arc AC, so arc AC, right? And so we see in this case, we have x over 12 pi is equal to 130 over 360. And it's the very same thing we did in the previous situation. And so here, 130 over 360, this is going to be the fraction. You know what? I'm going to just type it out because my handwriting is pretty bad here. So I'm still going to circle this though. So this is going to be, in this case, the fraction of the circumference. And so since the fraction of circumference, the 130 to 60, we're going to get, in this case, x is equal to, x would be the portion, the part of the whole, okay? So is part over whole here, all right? So since this is part over whole, x equals the part of the circumference. Again, I'm probably going to type that out too, because I'm noticing my handwriting is just dreadful to read. So here, ladies and gentlemen, here part over whole. And so we're saying in this case, x equals the part of the circumference. And that's what arc AC is. It's a part of the circumference. And so now to solve for this, to solve for the part to the nearest tenth of an inch, we're going to now get x over 12 pi equals, we're going to get 13 over 36. We're going to multiply both sides by 12 pi. 12 pi, 12 pi. So these divide out. And so now we're going to do the following. We got a calculator, right? So here we go. We're going to get 13. So 13 over 36. Oops, sorry. 13. What the heck? 13 divided by 36. And then we're going to multiply that by 12 pi. Okay, now not to worry about parentheses so much because the calculator does understand the order operations. It will do 13 over 36 before it multiplies over pi. So it's not going to do the multiplication before division because remember, order operation is going to be multiplication division in the order from left to right. So we'll do the division first, then multiply. And so our answer would be 13.6135, but to the nearest tenth of an inch would be 13.6. So therefore, the side here, x equals 13.6 inches. And so in general, what we have in this case, a formula if you want to talk about arc length in this case, when it comes to our degree measure, okay? So arc length will be the following. It'll be theta over 360 times 2 pi r. And where theta is equal to the measure of the central angle. And again, some parts I'll write out in letters, and some parts I'll just type out because just, you know, it's going to make more sense to type it out and all. So, all right. So here it equals to the measure of the central angle. Okay, which same as measure the arc. And then we'll have in this case, the r value, r in this case will equal to the radius of the circle. So, but it really is going to be a portion in this case. So if you want to, you can consider this to measure the arc length or the measure the portion of the circumference to be this formula here. If you guys are totally into formulas, and this works out too. We are going to be using this later on when we start exploring a different way to measure angles. And so that's coming up in a lesson later on though. All right, so if you found this helpful, all right, ladies and gentlemen, please leave the video a like and all. Take notes, all right? Some of these things, these formulas that maybe not mentioned in the classwork video, you might want to write down as well too, because they come up again, and hopefully they make sense in this case, because, you know, it's not like the only in geometry we'll be doing questions like this. You'll see them later on applied with other ideas, especially next year when you guys take Algebra 2 for some of you guys. All right. Anyway, thanks for watching. This is the end. This is the last question of lesson 29 for homework-wise. If you have questions or comments, leave them in the section below. And please, like I said, leave a like for this video. All right. If you have any ideas of other videos you would like me to do, if you want me to also redo any of the classwork videos we've done, because maybe you weren't exactly sure, I don't mind going over them and all, ladies and gentlemen. Not mind at all. Also thinking in this case, for some of you going on to next year, think about doing a few of the videos for our Algebra 2 individuals going on to the Algebra next year. And just starting there, maybe some ideas would be maybe going over radicals again and going over domain and range and all those wonderful things. All right. So in any case, I appreciate you guys for watching. And remember, take care and be safe.